In this video, I'm going to demonstrate some of the functionality of the EWSS pulse table. To do that, I'm going to build a small scenario in a location in the world. And as usual, I will add a receiver platform. And I'm going to create a new platform that will contain our emitter. And first thing I'll do is I'll add a new emitter, which just gives us the default emitter with the default emitter parameters. And what I want to do is I want to build a circular scanning emitter that has an alternate PRF. In other words, the first sweep will have one PRF and the second sweep will have another PRF. So the PRF will be tied to the scan pattern that the emitter is performing. First thing to do is change this to a circular scanning emitter, and I'm going to go ahead and ensure that the emitter comes on at the beginning of the scenario, so we can play the scenario and monitor what's happening as we make changes to the scenario. In this case, I'm also going to make the vertical profile a little wider because it's a circular scanning emitter. And we'll go ahead and test this default emitter just to make sure we're receiving it. And we are receiving the default emitter at our receiver platform. So let's go to the pulse table. And the pulse table comes with the default settings of frequency, PRI, PRF, pulse width, amplitude, and count. The count is the number of the same pulses that will occur before it goes to the next row in the pulse table. Down below you see a graphical representation of one of these columns versus time. So in this case we're seeing pulse amplitude versus pulse table time. That actually isn't that helpful in this case, so I'm going to change to PRI versus pulse table time. And so for every row I add, we'll see a change in the PRI versus pulse table time graphic. Since I have since I want the PRF to change on each cycle of the scan, I'm going to make some changes here. First thing I'm going to do though is just go ahead and change the frequency to make it 8500 megahertz. Just add a little realism here. Since I want to have this PRF occur for 1 second, which will be the scan period, and I want the next row to also be 1 second, I'll need a few more parameters, so I'll select some table columns that will help me with that. I'll add time, and this is the time of the leading edge of the pulse of this represented by this row, and I will add duration. And duration is the amount of time it takes to complete this entire row before going to the next row. So we have a PRF of 1000. Let's make that 6,666 pulses per second. And since I want it to go for 1 second, I'll add 6,666 pulses before it goes to the next row. And we can even test this. We can test this with the audio right here. Now that audio is being generated for the pulse only without taking into account the scan, because we're editing only the pulse table. So bear that in mind when you test with the audio. You're hearing only the pulse table without any scan effects. Also, you may notice on this video that the audio doesn't sound exactly right, and that's because of the recording capabilities of the program that I'm using. Actually, if I slow down the audio, you will actually hear a more appropriate frequency. In any case, I will now go to add a second row, and I just click over here. I now have a duplicate of basically the first row. I wish to change the PRI to 100, which gives us a PRF of 10,000, which means I need 10,000 pulses to fill up a second. So you can see the duration of both of these is 1 second, and this one starts at 1 second, which you can also verify in the graphical display of PRI versus pulse time, or if you wanted PRF, you can also do it as PRF as well. And you can see the PRF over here and the PRF for this line just by moving it around, and you can see 1 second of this PRF and 1 second of this PRF. Also, we can verify this with the audio, so we have audio changes going on. And the final test to verify that our emitter is working as we would like, we'll just bring up the signal analysis. We'll select the emitter that we're receiving. Move this a little closer, and this emitter can use a little more power. So we are indeed seeing two different PRIs or PRFs on each cycle of the emitter. And that concludes the basics of the EWSS pulse table.